first thing we need to do is identify the fact that there is some other job that this card is doing, and that job is pricing calculation. So we need to define an interface that defines what is that pricing calculation, what does it need to do and how should it behave. So what I've done is I've created an iPricing calculator interface that simply is able to calculate the price for a given order item. With this in place, now we can go back to our cart, look at its total amount, and see that when we loop through each order item and we sum up the total, all we need to do is take our pricing calculator and add the calculated price to it, such that we are summing up each of these rules. This replaces the logic we had before, where each if basically represented a different rule. So we have an each rule, we have a wait rule, we have a special rule, and of course there's more rules coming. So the pricing calculator has a simple interface, which we implement in the pricing calculator.cs. And here's where we're going to new up our list of pricing rules and how they get evaluated. So when we call calculate price, all it's going to do is run through each rule, see whether or not it matches. So this lambda expression says, find me the first pricing rule where there is a match with the current item, and call its calculate price method. So what is match? What are these pricing rules? Well, here again, we have to introduce an interface. And in this case, the interface is iPrice rule. There were two pieces of each one of those rules in our original cart. The first one was, how do we know whether or not this particular rule applies? And that was determined by the logic within the if statement. The second rule was the actual use of the amount in the equation that was used in order to determine the unit price or the total price for a given quantity of units given that rule. So if we look at the price rule, we abstracted out those two things in the two separate fields. One is a boolean that determines whether or not this price rule matches a particular order item, and the other one calculates the price. Now you could also achieve the same sort of behavior by just using calculate price if you had some magic behavior that said that, if the rule doesn't apply, we're just going to return 0 or -1 or something for calculate price. Personally, I prefer to be more explicit about this and make it very clear that this rule applies or does not apply to a given order item. Now that we have our abstractions in place and we have a pricing calculator that goes through our list of rules and applies each one's price, we need to actually implement each one of these rules. So the easiest one to do is the each price rule. And if we look at this particular rule, we see that the is match simply takes the exact expression that we had inside of our if statement and returns it. So we're going to return item.skew starts with each. And then we're going to call calculate price. And here now we're going to return simply the body of the if statement. So item.quantity times 5. If we look at the program price rule, you can see that it's very similar. The body of the if expression is the is match, and the contents of the if when it is true represents the calculated price. And finally, the special price, 3 for $1, is identical. We pulled up the data that was inside of our if statement, and we applied it here. So let's make sure our tests still pass. Come down here and we'll change which one of our carts we're going to use the refactored cart. And I think that's going to have to be model.refactored cart. There we go. And we'll make this the same. Model refactored cart. Alright. So now we're using the cart here that we just changed. We'll run all our tests again. And you can see they all pass once more. So what if we wanted to add a different rule? We mentioned that perhaps there's a test method that we want to see where we have a pricing rule that says that if you buy 4, you get this one free. Now, just for argument's sake, let's say that each one of these items costs a unit of 1. So we'll say that the cart total should return $4 with 4 buy 4 get 1 free items. And so we're going to say cart add new order item. So our quantity is 4. And our SKU, we haven't defined what SKU this is going to be yet. So we're going to say buy 4, get 1. So E4, get 1. Instead of logo. And what should these be? We'll say these are apples. Alright. Once we've done that, we're going to assert that this in fact returns back $4. And this will be our cart dot total amount. And we're going to run our test. And our test fails. Because of course we don't have a rule that matches this yet. So how would we go about introducing a new rule that matches buy 4, get 1, and gives us back 4 regularly, but otherwise is going to give us the value that we want so that when we buy the 5th one, it also costs 4. Well, the first thing we need to do is create a new price rule. So we come to our price rule and create derived type, and this price rule is going to be called buy 4, get 1 free price rule. And of course, we're going to want this to be public. And we're going to need to import these things. So this will be a match return item dot SKU dot starts with E4 get 1. And that looks pretty much like our each price rule, right? Yep. And on that same note, let's go ahead and pull out the each where we said times 1. And in the spirit of test-driven development, we're going to do the simplest thing that can possibly work, which I think I've done now, to get that test to pass. So when I run this, I need to actually add this rule. So we need to 4 get 1 free. We need to add this to our pricing calculator. So pricing rules.add new that. Build. Alright. Run our tests. And look, it works. So, of course, we haven't actually tested that does what it should do when there's 5 items. So that'll be our next step, where we'll say $4 with 4 buy 4 get 1 free items, and we think it should be $4 with actually 5 of those items as well. So if we change this quantity to 5, everything else should still work. Actually, it should fail because we haven't implemented our rule yet. And we get $4 with 5 buy 4 items failed, but actually it was $5 that it returned. So we need to go back to our rule. And while we're here, let's go ahead and move this to a file. And this buy 4 get 1 rule, it's great that we want to do that, but it turns out this rule is actually very similar to the 3 for $1 rule. So if we go about that, we'll just snag that code real quick. And jump in and drop it here. And what it turns out is that we just take the total 20 times 1, the sets of, in this case, 5, equals item quantity divided by 5. And then anytime we actually get that, we want to just take the sets of 5 minus 1. And that will achieve our rule. So it's basically buy 4 get 1 free is the same as saying that you get $1 off every time you buy 5, where $1 happens to also be the cost of each unit. So we'll build this and run our test one more time, and you can see they all pass. Now in this case, the way that we achieved this, we didn't have to touch the cart. Our implementation of total amount remained unchanged. Our pricing calculator, we add one item here in its constructor where we're setting up these rules, but you can imagine that these rules can easily be passed in through some kind of configuration or database such that we wouldn't have to touch the pricing calculator itself. The logic of the pricing calculator, this calculate price method, remained unchanged. So the only real new code that we had to write in our buy 4 get 1 free rule was in this new class that did not previously exist, where we implemented its interface in this code here. So when can we apply the open-close principle? It's important not to just willy-nilly try and add abstractions everywhere within your code, because the result is going to be something that's very difficult for anyone to follow and be more complex than needed. The first thing that you should think about is, what does your experience with this particular type of problem tell you? If you know in your experience in the problem domain, the particular class of change is likely to happen, you can apply OCP up front in your design. However, if you don't know this, and oftentimes if you're working on in new problem domains, you're not going to know, you should follow the fool me twice, shame on me practice, where at first you should just code up the simplest thing that possibly work. Hard code the values if you need to. Put the logic inside of an if-then statement. Do something that's simple and works. And make sure you test it. If the module changes once, do the simplest thing that can make it work. Add an else statement to your if statement, if that's all it takes, and continue on, making sure again that you've got tests that demonstrate the behavior. However, once it changes a second time, now you're at the point where you know this is something that's volatile. It's shown that it has a propensity for frequent change. It's time to refactor it to achieve the open-close principle, and the way you do that is by finding an abstraction, creating an interface, and then extracting out the if-then logic or switch statement logic into separate classes where each one represents a particular node in that decision tree. Remember Tan-Staffel, there ain't no such thing as a free lunch. Implementing the open-close principle will add complexity to your design, and you cannot have a design that is closed against all changes. So you want to make sure that you choose those types of changes that are actually likely to occur for your design to be closed against. Otherwise, you'll add complexity with no benefit. So to summarize, if you write your software such that it conforms to the open-close principle, it will yield flexibility, reusability, and maintainability in the application. You want to try and know which changes to guard against, and of course resist premature abstraction. There are some related fundamentals to this, a single responsibility principle, which is also part of SOLID, as well as a couple of design patterns. The strategy pattern, which we saw utilized here, and which is explained further in our videos, and the template method pattern, which I mentioned, but which you'll have to go watch another video in order to see how it's applied. I recommended reading, I highly recommend the book Agile Principles, Patterns, and Practices in C# by Robert C. Martin and Micah Martin. And to wrap up, I'd like to include some credits for the motivational poster on the open-close principle that we saw in this presentation. And I'd like to thank you very much for your time, and I hope that you'll continue to learn from us through additional Pluralsight on-demand videos. Hi, this is Steve Smith.